Quick, graph y equals 1 over the quantity of x minus 1 plus 2 by hand 2 different ways. This is part of the family of functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed any time during this video. First, we need to decide what the parent function is and its shape. Parent function is y equals 1 over x, the reciprocal function. Its shape is a hyperbola with 2 branches and also 2 asymptotes, a horizontal and vertical asymptote. Please keep this graph of y equals 1 over x in your mind as we're doing this. We need to identify the parameters, and in this case there are two of them, values in the expression that affect the graph. How do they affect the graph? Well, the plus 2 affects the y values. It shifts all points up 2, while the minus 1 inside the parentheses, inside the denominator, shifts all points to the right 1. So what do we consider first? Well, we suggest plotting the center of the hyperbola first, and that we call the center right here is normally the origin on y equals 1 over x. But at this time it's going to be right 1, so it's going to be 1, and then up 2, 2. So the center of this hyperbola is going to be at the point 1, 2. We'll plot that first. And all points will be plotted relative to this new center. We also need to draw the horizontal and vertical asymptotes through the center. They'll be perpendicular. So one of them will be at y equals 2 instead of at y equals 0. The other one will be at x equals 1 instead of x equals 0. And we'll go ahead and do the reciprocal dance from the center, that orange center point. Normally we go right 1, up 1, and that's what we'll do here as well. Right 2, up a half, and that's what we'll do. And right a half, up 2. So those are the 3 in the so-called new first quadrant. In the so-called third quadrant, we'll go left 1, down 1, left 2, down a half, and left a half, down 2. We'll connect the points into 2 branches of a hyperbola using the asymptotes as boundary lines. And we compare it to the parent function y equals 1 over x. Second way, using a table. These are 6 points that are on our traditional y equals 1 over x hyperbola. The minus 1 inside the denominator there affects the x values. It shifts the points to the right 1 unit. So we need to add 1 to each x value to shift it to the right. So 2 plus 1 is 3. So I'd like you to go ahead and find all the x coordinates. Press pause as needed and resume when you're ready. And here I'll just go ahead and show you the values that you should be getting for the x coordinates. The plus 2 affects y values. It adds 2 to each y value. So a half plus 2, think of a half plus 4 halves would be 5 halves. So we'll plot the point over 3 up 5 halves. 1 plus 2 is 3, so we'll plot 2, 3. Go ahead and finish these 4 points, plot them, and finish the graph. Press pause and then resume when you're ready. Two plus 2 is 4, so 1.5, 4. Negative 2 plus 2 is 0, so 1/2, 0 would be an x-intercept. Negative 1 plus 2 is 1, so 0, 1 is a y-intercept. And negative a half plus 4 halves is positive 3 halves, so negative 1 up 1.5. Draw the asymptotes. Those will be at y equals 2 and at x equals 1. Those will be the boundary lines. We'll connect the points into a hyperbola, and we'll compare it to the parent function y equals 1 over x. Now you try one. Graph y equals 1 over the quantity of x plus 3 minus 5. Use either method or both for the practice. Press pause to do this and then resume when you're finished to check your answer. And here's your answer in green. I've also included the table of both the parent and this green function.